Guys, before you begin with attempting this question here, I want to highlight that this specific question actually comes up very, very often in your exam. They'll ask you to explain in terms of molecules how the gas in the balloon exerts a pressure, guys. If you think about the basic understanding of how pressure is exerted in a container, let's imagine today I have a container here, right? I know for a fact that the reason why there is pressure inside a container is simply because the air molecules are what? Good. They are colliding against the walls of the container, right? When they collide against the walls of the container, the first formula that you should always remember is pressure is equals to force over area. And because the force increased per unit area against the wall, this actually increases the pressure. So how are we going to relate this formula back in terms of momentum here? You have to ask yourself, well, how is momentum related to force or pressure? If you think about all the formulas, I think there is only one formula that relates momentum with pressure, right? What is that formula? No. There is one specific formula that relates momentum with force. What is that formula? Shit. Don't call my name. Don't call my name. Oh, bloody hell.
Change in
What?
momentum over time.
Very good. It change in momentum over time because if you remember the impulse formulas, guys, impulse is Ft is equals to mv minus mu, right? Right. So the only way to relate force into momentum is change in momentum over time, right? So with this formula here, you can more or less bullshit your way through already, right? By right here, you can say that an increase in change of momentum as the air molecules collide against the wall increases the force generated per unit area, ultimately increasing the pressure, right? So it's all interlinked together, guys. I repeat again, you're going to say something like an increase in change of momentum increases the force per unit area inside the container, right? As the air molecules collide against the wall, then obviously there is an increase in pressure here, guys. If you look at the mark scheme here, it is a very, very common answer as well, guys. You see, they'll definitely use the word change in momentum because as the air molecules collide against the walls of the container, this causes a change in momentum, which will ultimately increase the force per unit area as it hits the wall, ultimately increasing the pressure. So this is a very standard question, guys. Can I write something down? I'll give you like probably, I don't know, 6 minutes. 6 minutes to do this question, then we move on to the next one. Pressure, volume, and volume. Bro, double volume and pressure, bro. What's the formula? Boyle's law.
What law?
Boyle's law. Yeah. P1 V1 equals to what? MGH. So watching your videos. Better watch the videos. You better watch the videos by next week, I tell you. Next week it's like everything. It's P1 V1 equals to P2 V2. Oh. 一天看2个小时，一天看1个 video. Refer to the notes. It's actually you actually need to watch it because it seems like you don't remember a lot of things. Okay, everyone. I think it should be done by now. Yeah. Let's go through the answers real quick. So the first one, I think I've mentioned it to you guys already, right? You can literally write anything, guys. You can say something like, as the air molecules fight against the walls, this causes a change in momentum, which increases the force per unit area against the wall. Something along these lines, or however way you want to structure it. Is it even wrong?
I don't know.
Okay, if you're not sure, then you better copy the answer down. Okay, then the next one here. They say explain in terms of molecule once again why the pressure of the gas increases when the volume of the balloon decreases, guys. Guys, I think I've mentioned this in class before, but can you imagine today if I have a big balloon versus a small balloon? The same amount of air molecules in the big balloon will occupy the smaller balloon here, guys. And from here, which one do you think is going to collide against the wall more frequently? The small one here, right? And because there's more collision against the walls of the container, then ultimately this pressure is going to increase, right? You're supposed to say, guys, you're supposed to say that either the air molecules move a shorter distance in between the walls of, in between collision against the walls of the container, or you could say something like the same amount of air molecules occupy a much smaller area, a much smaller volume, thus increasing the rate of collision. If you look at the mark scheme here, I'm very certain they will say the exact same thing, right? They are definitely going to mention more frequent collision against the wall and thus producing a greater force per unit area, once again, ultimately increasing the pressure, guys. But if I were to write this down, I'll write something like this. Something along these lines, or however way you want to structure it. Okay. Yeah, record. Oh, Tavish, did you just join? Very good. Even better than Kunling. Is Kunling even in yet?
Bro, I joined so long ago.
Bro. So Tavish is the ultimate true champion here right now. Very good. But whatever. Okay. Anyways, last question. This one here is literally identifying that this is V1, this is P1, and this is V2. Right. So this is literally just boils off P1, V1 equals to P2, V2. I won't go into the calculations, so you do it yourself, but the answer should be how much? 2.75 times 10 to the power 5. Is that correct? Yeah. You should get the new P2 as 2.75 times 10 to the power of 5 pascals. Do your own calculation for this one. And 275,000. No, write it in standard form. Whenever you have a very big number, it is more recommended to write it in standard form. Especially any number that is more than 10,000. Okay, because most of the time the mark scheme did fit in standard form also. But to be fair, I've never seen anyone get penalized before for this. So So it's just like a nice to have kind of thing, you know, nice to do kind of thing. Okay, everyone. If you have no questions, let's go through the next question here. By now you should be able to recall all the refractive index formulas, guys. There are only 3 refractive index formulas. N equals to sine I over sine R, N equals to C over V, and N equals to 1 over sine C, guys. Right. You should be able to do this one. And try to draw this one. Try to draw this one and let me see what you have. Yeah, you have how long? How much time do you need? 7 minutes, 7 minutes to do this question here. Either you know or you don't know. But don't do that in the real exam. Just draw a dot. So draw a dotted line here, bro. It's virtual light.
Oh,
This one, bro. Dot, 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 dot.
don't hold it on.
Yeah, you're supposed to draw the normal also lah. Both also is supposed to draw dotted for the normal. Dot, 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 dot. Cái học có thể hiểu. Số độ. Số độ. That enough part. I've already said this 1,000 times in class. 我想死了他们，有可能啊。Do you think that's possible? The lines are going to go straight in and straight out in the water and air. 可能吗？ Can you bend it a little bit more so that it's not obvious? This one, this one straight line. Oh, really very a little bit. You draw this one here a little bit more. Then this one here a little bit more. Then you bend it both down like this. Bend more, bro. Yo. What's a nine? Do you think this is possible? This is like literally reflecting backwards already in the light.
明显一点啊。
真的太明显了，对不对？Bro，你想一想可以吗？Can you think about it a little bit? This you draw like that, right? You draw like this, this is literally the light reflecting backwards already, like.
有没有这样明显一点呢？
哦，真的太明显了哦，不可以接受我明显了。Alright. The only way for you to go 90度下 if it's the light is coming from here, then 就90度啊。So what you should do is right, you plan like it somewhere here, then 它就不会90度下了。你知道我讲什么吗？See, drawing is the worst enemy of all. Looks much better, right? Oh, dear Lord. Okay, everyone. I think you should have enough time to do it already. For those who do not know how to do, I can only assume that you didn't do any drawings before. Okay, hey, if you look at this first question here, very straightforward, guys. First and foremost, they already give you the speed of light. By the way, most of the time they do not give you the speed of light because speed of light is supposed to be a known constant, guys. In your exam, if they do not give you this, you should know that the speed of light should be 3 times 10 to the power of 8. And if you don't know it by now, you're almost as good as dead already. Okay, then this one here is the speed of light in the transparent liquid, which is obviously the V. Then they also give you the incident angle. 40 degrees, they ask you to calculate the refractive index in the liquid. So obviously in this scenario here, you're supposed to use N equals to C over V, which is 3 times 10 to the power of 8 divided by 2 times 10 to the power of 8. And you're supposed to get 1.5. You use 1 over sine C. C is the critical angle, right? And you're supposed to get 1.5, right? Then there's no units for refractive index because the meters per second will cancel off the meters per second. Same for this one also, all the degrees will cancel these degrees here. So there is no units for refractive index. Okay. Then after that, they ask you for the angle of refraction in the liquid, which is obviously your R here, right? Since you already have refractive index already, then your N must be equals to sine I over sine R, right? And if you have sine I over sine R here, then obviously it's supposed to be 1.5 is equals to sine 40 over sine R, right? Then from here, what do? Sine R is equals to sine 40 over 1.5 and R will be equals to shift sine. Sine 40 over 1.5. Press that in your calculator And you should end up with an answer of 25 degrees. You all get 25 degrees. Yeah, should be the mark scheme is always only 2 significant figures only. But you can leave it in 3. This means about 25.4 is acceptable, guys. Like I said, the mark scheme is always just giving 2 significant figures, but you can write up to 3. In fact, I encourage writing up to 3 because it's more accurate. Then this part here where the drawing, a lot of people always give me very, very funny answers. The most common funny answer I see is that this one more, which just literally happened just now. Is it possible to draw it like this? And why is it not possible? Why? What's wrong with drawing it like this? Do you think it will ever happen like this? Why is it not possible? Why? Why? Bro, if you draw it like this is literally mirror reflection already, right? It's reflection already, bro. You know, like if you take a piss on the ground and you see your own image, yeah, that's a reflection already, right? So this definitely not going to happen like this, right? And then a lot of students also, the next common thing which I see a lot of students do, they like to do it like this. They draw the line up exactly to the edge here, right? Then they'll give me like 190 degrees downwards here. Why is this not possible also? Yeah, because there's no refraction already, right? The only way for the light ray to go directly straight down is if the light is coming from this here, then it will go directly straight down, right? So when you draw this experiment, you have to be a bit more smart about it also, right? You don't defy the law of physics, basically, right? So what you do is always you start from the image here. You start from the image, you draw 2 light rays that are all going outwards already. You draw a V shape first. If you draw a V shape here, then it will be much easier to trace to the eye, right? And literally, this is it already, lor. Namo. Okay, then you draw your normals and everything. Oh, but this is not the final answer yet also, because from here you are supposed to locate the image, and when you're asked to locate the image, all you need to do is you draw the dotted lines, right? You continue the straight line and draw the dotted lines. This is essentially where your image is, right? That is why you should open up the rays upwards here, because ultimately you want them to converge at one specific point, and that specific point must be more shallow than where the object is. That's why whenever you look into the water, that's why when you look into the water, the image is a bit more shallow, right? 哎，我我不要看了，我真的要倒血管了再看下去。Joe, this is not the acceptable answer because they usually want you to show 2 light rays. In fact, the question there say draw 2 rays from the object, right? Leo's one is a bit more acceptable, but try to extend your light rays until they converge, Leo. You're supposed to converge it. So it means to say your image should be slightly a little bit lower. Please take a mental picture of this diagram. I tell you, it always comes up on this. And if you have a mental picture of this diagram, you can more or less scam your way through or whatever way you do get through this question, I guess. Very good. Your image is a bit too low, isn't it? Your image should be above the object, huh?
Draw the arrow.
Huh?
Make it kind of like arrow.
No. No, also. So the normal line have to draw. Is it a must? No, it's not a must, but it's good habit also. Then draw dotted lines for your virtual light. It should be dotted lines, but your drawing is correct already. Okay, guys. If you have no questions, show me your one. Yeah. If you have no questions, proceed on to the next one. My favorite question of them all. What type of question is this, by the way? If you look at the diagram. What type of question is this? If you look at the diagram, what's the keyword that gives it away? What topic is this asking on? What's the keyword here in the diagram? There's one specific thing. Yes, very good, Joe. That's the correct answer. Why? Why is it moments? Why is it moments? Pivot. Because of the word pivot, guys. As soon as you see the word pivot, you should know for a fact that this is going to be a moment question. Try to do this, everyone. Let me know. Let me know how to do it. You have exactly 6 minutes again. Write something down, don't just stare at it. Yeah, that's the first step. What?
122.
Good. Do what?
8 times to know what.
Good. Supposed to find. Hmm?
Very good. Wow, who would have thought that writing down something would actually lead you to somewhere? Men are women also, ma. Joe.
Moment is a moment, force is a force.
I was expecting most of the Tandy boys to get this correct, actually. Leo's got the right answer already. God, it seems that none of the Tandy boys can do it.
Wait. Let's go through the question together, guys. Now, first and foremost, I've always said this a million times by now. When you see these kind of questions, right, literally don't just stare at them and write down what you know. Most of the time when you write down what you know, right, you'll realize that this answer will lead you to another and eventually you will actually know what to do. But as long as you continue staring at the question, you'll go nowhere and eventually you will write nothing at the end of the day. So in your exam, literally whatever you know, just write it down. Okay. So first and foremost, what do you have here? Straight away, I see there's a pivot here. I know for a fact that this is going to be a moment question already. And because it is a moment question, most likely it's going to be moments in equilibrium, right? What does moments in equilibrium state again?
Yes, Junhao. Wow, you are the first one to get it right among the Tandy boys.
What does moments in equilibrium state again? What equals to what? What equals to what? You don't know what moments in equilibrium state. Yes, very good. Anti-clockwise moment. In fact, the total anti-clockwise moment should be equal to the total clockwise moment, right? Right. And because of this, then I know for a fact that from here, if this is the pivoting point, I ask myself first, will this 200 generate a clockwise or will it generate an anti-clockwise moment? Will this 200 Newton generate a clockwise or anti-clockwise moment? Clockwise, anti-clockwise. Usually Denmark on now, right? How do you guys do this? It's clockwise, right? Why is it clockwise? Why is it clockwise? Because of what? GG! Bro, don't tell me until now you don't know how to see whether it's clockwise or anti-clockwise. This force is pushing here, right? And this is the pivoting point, right? This thing will spin like this, right? Around the pivoting point, so this is going to be clockwise, right? Then if this is a clockwise, then naturally it should be balanced by this anti-clockwise moment, right? Which will spin around this point here. Right. So from here, I just write my formula down. Anti-clockwise moment, F times 8. I don't know how much is that. Clockwise moment, 200 times 22. Because, let me just write down the formula as well for those who do not know. It's F1d1 is equals to F2d2. The only reason is F1d1 equals to F2d2 because there's literally only two forces here. Right. But if there's three forces, don't you dare write F1d1 equals to F2d2. And from here, literally substitute everything in on F times 8 is equals to 200 times 22, right? And from here, you'll find that F is equals to 550 newtons. Yes, Joe, is it going to be 550 newtons? This is supposed to be your force, right? And from here, if you're asked to find pressure, force over area once again, so if your pressure is going to be 550 divided by 0.0005, right, which will give you 1.1 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. Ta-da! And that's how we do the question. So, anyone's got any questions with this one here? Anyone don't understand? What? Moments in equilibrium. What? That's not an E, bro. That's a symbol for total. This is a symbol for total. Which part is the last part? You mean the pressure equals the force over area part? Please do more. When you explain it, I get it, but if you give me another one, then you better start writing something down, Jen. Usually, most of the time in your exam, they'll just test your understanding on moments in equilibrium. If you can remember this, you should be able to recall this. And if you look at the question here, you should be able to get these things here. Just think about it step by step. But most importantly, don't stare at the question. Literally write down what you know. Then it will slowly piece itself together already. Okay, boys and girls. Anyone got any questions? Good. If you have no questions, do the next one. Once again, another drawing question. CM area was and don't you have to convert? Bro, this is mathematics, bro. This one here, I already cancelled them off already. This is in CM and this is in CM, right? But when I bring it over, it already cut itself already. So there's nothing to convert. I'm just looking for force only, bro.
Do you understand what I'm talking about, Joe? In a scenario where one of it is in meters and one of it is in cm, then you have to convert lah. But if both of them are cm and cm, I'll just cut each other off, right? Do you understand what I'm talking about, Joe? Do you understand? Seriously? Please do the next one. Pink light is colorful light. What does the word mono mean to you? Like as if you're a really bad singer and you're monotonic. What does that mean? One, right? So how can it be colorful light? Colorful light is 7 colors, right? So what's the definition of a monochromatic light?
One.
Light with one what? Huh?
Ring.
Yeah, wavelength and frequency. Oh, what happened? Why the answer become further away now that I check your answer here? For the moment one, what happened? Where did you get the 14? Oh my god, you took 8, is it? Sorry. Exactly what I said that day in class. Did this question in class, right? Did we do this question in class today? I think we did, right? What did I say when we were doing this question? What do you do first? Draw the what? Draw the normal line. Are you sure, Abigail?
Something about cheating in this kind of questions, one. What did I say you can do to cheat in this kind of questions? Yes. And then only draw the light rays, right? I think that's the easier way, right? Okay, guys, for those who have not done this yet, you clearly do not know what to do. Okay, let's go through this question rule together. Okay, write down 3 terms to describe the image produced. Guys, this is literally as free of a mark as you can get already. You just need to say whether it is real, real, virtual, inverted, upright, magnified, or diminished only, guys. And starting off with whether it is real or virtual, it is most certainly going to be real because they are on opposite sides of the lens, right? And I've said this before in your exam. If they ask you whether it is real or virtual and why, it is real because it can be projected onto a screen. Or it is virtual because it cannot be projected on a screen. Very damn standard question with a very damn standard answer. And obviously it's supposed to be inverted, right? Inverted because it's upside down, right? And in this case here, it's definitely going to be magnified, right? Because upside down. Upside down and then it becomes larger. If you're not sure, you can use a ruler to measure here and use a ruler to measure here. You'll definitely see that the image is bigger than the object, and thus it should be magnified. Yes, thermocouple is off the syllabus. Okay. Then from here, in this question, I've said this almost 1,000 times before in class, and I'll say this again. A lot of students, they like to magnify and enlarge the same thing. Magnify and enlarge are the same thing. You can write both of it. It's the same. Okay. In this kind of questions here, a lot of students, they like to do this. They like to draw from here, then they like, then it doesn't look quite right. Then you draw, and draw, right? The image should be somewhere around here, which is like slanted away from the object. What's the easiest way to do this, guys? What do we do first? How do we cheat in this kind of questions? What do we do? Abigail, what do we do again? Draw the line from the eye to the, like this. Is it? No. You're supposed to draw the image first. And how do we find the image first? It should be same length from the mirror, right? So literally, you're supposed to measure. Hey, pay attention. I don't want to say this again. So literally, you're supposed to measure how long this is. Let's say, for example, it's 5 cm. Then you're going to use the exact same ruler and you're going to make 5 cm here, and then you draw your image here. But you better not draw this line in the real exam, because if they draw this, they know that you're cheating. So if you cheat and you get caught, then you deserve, right? Then from here, it'll be much easier to draw, right? From here, literally just draw a straight line until here. Draw another straight line until here. Then after that, make sure this top part is, it should be dot, 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 dot. This top part should be dot, 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 then straight line. Then from there, it's like literally just connect these two lines here, right? This incident will for sure be the reflected. This incident will for sure be the reflected also. This is the sure damn way to make sure that your answer is for sure correct. Not necessarily, but it's good practice to draw the arrow also. Please make sure you know how to do this in your exam, because it's as free as a mark you can get everything. Send in the people. Okay, everyone. Please do the next question. What's your refracted rays? Or something. We'll just wait for the answer.
But why did you rub this away just now? So where is it? So it's not that one was the refracted one already, right? Where should the refracted one? They're supposed to draw this line here, this line here, and we give the drawing. It should all be arrow with other this, and this, for some kind of why you got these two away for the start. So that's the reflected line now.
What?
Jesus Christ. This is a mirror, is it? Why like that? Can you tell me? Can you tell me? Oh. Oh.
If it was
What a 把年！我第一次看来这样子的。
That's right. What is that? Okay.
No, it is not. Isn't it?
No.
Different from here, no?
Oh, okay, so many right now.
Hey, I see, most of you guys are drawing very, very funny things to me, right now. And I must say, I'm really surprised to see some of your answer, boys and girls. Until I got a bit high blood pressure already, actually. Yeah, oh my god, Kunling is the first one to actually draw something decently, right? Jesus Christ. Okay, I don't want to see your answers already. Everyone pay attention to this. I cannot already. I really cannot already. I see your answers.
Jesus, man. Oh my God. Okay, starting off with the first one, guys. What is a monochromatic light here? What is a monochromatic light here? Monochromatic, as the name suggests, mono means one law. For example, those people who cannot sing, we call them monotonic, right? And if we are closer friends, we'll say monotonic, right? So from here, this is a very standard question now, by the way, and you must know how to write this. You should know that for a fact that this is a single color wave, a single color, right? And because it is a single color, this usually means that it only has one wavelength or one frequency. Okay, everyone. It should have one wavelength and it should have one frequency only. Right, so from here, you're going to say that light rays with one wavelength, write the full name, don't write the symbol, and one frequency. Okay, then after that, this one here. This one here is where I straight away got cancer already. I don't know what you guys are drawing up, but I cannot read. Anyways, if you look at this question here, it says that a wave in air is incident on the glass block. Figure 7.1 shows the wavefront of the air glass boundary. The arrow shows the direction of the travel of the wavefronts here. The wave undergoes reflection and also refraction here. They first ask you to draw the wavefronts of the reflected waves. Guys, for those who have any understanding of how reflection works, some of you guys drew something very funny. I also don't know what. Oh, sorry, some of you drew something like this, which got me real good already, I must say. The wave is reflected, right? So if it's reflected, shouldn't it follow this boundary here, like this direction here, and then it will hit the boundary somewhere, and then it will be reflected off somewhere also. If you want, you can even go the extra mile and draw a normal here, measure this angle here, measure the exact same angle and draw the line here. Then once you have this line here, it's easier for you to draw the wavefronts, right? Because I've mentioned this before, wavefronts should be 90 degrees to the direction of the wave. So anyone that draws something like this, like the can't feeling one, depend on feeling and draw one, you are already wrong already. So what you should do, you should draw one light ray here that is, one wavefront here that is 90 degrees here, then measure the exact same distance here and draw another one, right? Because reflection does not change the wavelength. Then once you have that already, you draw and you draw and you draw. Of course, you don't sketch it, you draw it nicely like the diagram shows, right? Then it's easier, right? Then after that, they ask you to draw the refracted wave. The refracted wave, you ask yourself, when the light enters from less dense to more dense, the speed of light for sure decreases, right? And if for sure decrease by right, the speed of light should be like this one, it should be one straight line continuously down like this, right? But because it's slowed down, right, will it bend towards or will it bend away from the normal? Will it bend towards or will it bend away from the normal? It will bend towards. Why? Why will it bend towards the normal? Tell me why. Why? Why does refraction occur again, guys? What's the reason refraction occurs, is because there is a change in speed of light of the wave, right? Sorry, there's a change in speed of the wave. In this case here, the speed of the wave obviously slowed down, right? Right, and because of that, it should bend towards the normal, right? And because of that, then you can draw this one here and this one here. But this is just for your reference, because ultimately, I think what they want you to do is they want you to draw this and 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 this, indicating that the speed of the wave slowed down. Oh, it makes a little bit more sense, right, everybody? Does this make more sense? Anyone don't understand what I'm talking about or not for this part here? Anyone don't understand what I'm talking about? Go through some of the answers that I've seen. I think Kunling was the only one that sent me the right answer, by the way. For the monochromatic lighting, does it count if I say light with only a single color? That's not wrong if you say a light with single color. Actually, in fact, it's acceptable as well. Money is acceptable. And then this last part here, a transverse wave is produced in a long horizontal rope. The rope is much longer than the wave. On space below, sketch a diagram of the appearance of the transverse wave. Take two key points. Okay, so literally draw a transverse wave and label it. You can either label it as the peak, the trough, or however you pronounce it, the amplitude, or the wavelength. Either two, like literally any two, and you can get your 2 marks already. Okay, everybody. Anyone don't understand what I'm talking about? Why didn't you draw this transverse wave just now? Sorry? Yeah, peak or crest is the same thing. Okay, everybody. Back to the basics. Which page is this? Okay. A lot more. More than that. Okay, everyone, if you're done with that question, do this question here right now. The lorry one. You have 9 minutes again.
Wow. Acceleration. How do we get the acceleration? In a distance time graph. The what? Forward force. Oh. I think they give you enough information to find out, right? It goes to 30 seconds. One mark only. Wait. At 30 seconds is where? Where is 30 seconds on the graph?
No, let me see.
Huh?
No, let me see.
900 meter. Okay, in this distance time graph, what can you find? What does the gradient represent? The gradient represents the speed, right? So at 30 seconds, is the gradient changing? At 30 seconds, is the gradient changing? What does that mean? This is a constant gradient, right? Constant gradient means it's constant what?
Okay.
Oh, if it's constant speed, what's the acceleration? It is constant acceleration. How does that work out? Your mother is driving on a highway at a constant speed of 120 kilometers per hour. She is also constantly accelerating. How much is the acceleration?
Zero.
Zero. Because it's moving at constant speed. Because the gradient is constant. How do you get zero acceleration in terms of resultant forces? Acceleration in terms of resultant forces. Okay. Let me rephrase my question now. If I have an object here and it is moving at 0 meters per second square, acceleration wise, if let's say the forward force here is 100 newtons, what other force is acting on this thing? How much?
100.
100. In other words, the resultant force is 0, right? The resultant force must be 0 for it to have 0 acceleration, right? So right now, look at this question again. Read the question, the whole question again, and tell me what's the forward force.
1.4 times 10.
Why is only one now? Because it's the same answer. No calculation, bro.
Okay, ladies and gentlemen, I think you should have enough time to attempt this question. Let's go through the question together. Straight off the bat, I want to say that these kind of graph questions are very important because usually it will be the first question in your IGCSE. It will either be a distance time graph or it will be a speed time graph. And as soon as you see the graph, you should ask yourself, what does the gradient represent and what does the area under the graph represent? Straight off the bat, you should know that in a distance time graph, the gradient represents the speed, the area represents nothing here. Okay? Then from here, they ask you the speed at t equals to 30. At t equals to 30, speed is equals to distance over time, right? So it will be 900 divided by 30, right? Which will give you 30 meters per second, which is very straightforward. Just write it down. Then they ask you for the average speed. Now, the word average speed means to say average speed is equals to total distance over total time. If they ask in between 60 to 120, you should ask yourself, this total time is 60 seconds and the total distance from 60 to 120 is between here and here. I think if you squint your eyes very much, you'll be able to tell that it will be somewhere around 2007 minus 1800, is it? Yeah. It will be 2700 minus 1800 divided by 60. And if you press into your calculator here once again, you should get average of 15 meters per second. Be careful with the word average. Average is total distance over total time. Then from here, they already said that time equals to 30, the resistive force is this amount. And they ask you the magnitude of the acceleration. At 30 here, guys, you'll notice that the gradient is one straight line. If it is one straight line here, it means to say that it has a constant gradient, right? Constant gradient means to say it has constant speed, which is ultimately the same as zero acceleration. And because of that, you should know that the acceleration should be zero simply based on the gradient being a constant gradient. And when I say constant gradient, means to say it's a straight line. This is a changing gradient. When the graph curves, this is a changing gradient. Right, straight line for sure is constant gradient. When the graph curves, it's a changing gradient. Then from here, since you understand that there is zero acceleration already, right? Then your forward force should be equal to your backward force, because there's no resultant forces. So it's 1.4 times 10 to the power 4. And describe the motion between 60 to 130 seconds. Here, 60 to 130 seconds, you can slowly see that the gradient is increasing or decreasing. The gradient is slowly decreasing. This indicates that the speed is slowly decreasing also. And this is exactly what you're supposed to write. You're supposed to mention that the speed of the lorry is slowly decreasing until it finally reaches a stop. Because you can see at one point here, the gradient is flat line already. Zero gradient means to say zero speed also. So you're supposed to write two things. The speed is slowly decreasing until it stops. Okay? The speed is slowly decreasing until it stops. However way you want to structure it, doesn't matter. Okay, everybody? Yes. For a speed time graph, the gradient is acceleration and the area under the graph represents the distance traveled. You must know these two graphs because 80% of the time your question 1 is going to be asking about these graphs. If you have no questions, move on to the next one. Bring d2y is 0 again. Sure. You see this one here, right? They're asking you for the acceleration at t equals to 30 miles, right? Acceleration at t equals to 30, I look at the graph here. 30 is here, right? 30 is here, and I know that at this point here, the gradient is one straight line, right? If this is one straight line here, it indicates that the gradient is at a constant gradient. Constant gradient, since gradient represents speed, constant gradient means to say constant speed. Constant speed means to say it's moving at one specific speed all the way, you know. So if it's moving at one specific speed all the way, then it should mean zero acceleration now. You understand? Yeah, for sure, no. Because this here is constant speed. Constant speed is like 120 meters per second all the way for a good 40 seconds here. This whole line is a constant gradient, which means to say it's constant speed all the way.
Yeah.我看到这样子啊，是这样子啊，你要写这样子在这边，is it？会的哦。Yeah. You either learn the mistake now, or you'll learn it in your IGCSEs. One way or another, you're going to learn it. First now? Kevin, 你想我反思。Explain how mine. Explain how you try to write something now first. Yeah. Usually, when we draw the lines, usually the object is somewhere here and there will be an arrow and but if the object is exactly in the middle here, your image will be somewhere in the middle here also. It will be either here, or here. So you need to read the question and identify where should the image be. That's all I can tell you.
Okay, guys. Hey, let's go through this question real quick. I think relatively straightforward. So nothing much to talk, nothing much to do here. Name this process where it starts to bubble. Obviously, this is going to be boiling, right? And then it escapes to the surface. This is evaporation lah. If you don't know this by now, you are GG already. Okay. Then from here, they give you the information. This is your specific heat capacity. This is your time. This is your theta, which is supposed to be 18 degrees Celsius. They ask you to calculate the power. Oh, this is your math. Okay, first and foremost, you ask yourself, what's the power formula? Power is supposed to be equals to energy over time. So what kind of energy will I get here? I have M, I have C, I have theta. Obviously, this is supposed to be a heat energy lah, which in this case here will be MC theta over time. In this case here, it will be 2.7 multiplied by 900 multiplied by 18, divide by how much? 150. Why should it be 150? Good. Time is in seconds. Press all of that in your calculator and you should get a two significant figure of 292. Right. Actually, sorry, three significant figures of 292. Or do you get a different number? 290. Zero, exactly. Is it? Okay. Then this is the one which I actually want to highlight. State and explain the precautions you take to improve the accuracy of this experiment. I've mentioned this before, I'll say this again now. Whenever you're dealing with heat questions, the best way to improve the accuracy is to do what? What's the best way to improve the accuracy? Use the what? Use the metal block. Use the metal block to do what? So what do I do to the metal block?
No, top on, top on.
Is that the right term? Use the metal block? What should we do to improve the accuracy for any heat-related questions? For sure, I've said this in class before, in fact, multiple times. What? What? Yes, you're supposed to use insulation. Why? I've told you the theory before, right? I don't want to say this again. Now, if you lose your marks for this, you deserve it for sure, 100%. The heat that is, all these formulas that we use here, we're assuming that all the electrical energy that is transferred is fully converted into heat energy, and all this heat energy is fully retained in this metal block here. But in reality, you know that is definitely not going to be the case, right? Because as soon as, even before I reach here, right, some heat will be lost to the surrounding already, right? And then I reach here, the heat that comes to this metal block here, it will be lost to the surrounding also, right? So whenever you're dealing with heat questions, I said this before, you want to improve the accuracy by reducing the heat loss. And when you want to reduce the heat loss, the only way to do it is by using insulation, right? So your statement should definitely be use some insulation to reduce heat loss for sure. And this answer 100%. Anytime it has to do with heat questions. Use insulation around the metal block. And the explanation is to reduce heat loss to the surrounding. Hey everyone, I hope you remember this, because if the heat questions come out, for sure they'll ask you this also. Okay, let's do the last one here before we end the day. This question here. Before we end the day. Exactly 6 minutes to attempt this question. Draw something, anything.
That's acceptable as well, Scott. Your focal point should not be there. So, do you think that if the focal point is here, you will get a clear image? For this one no. You get a clear, sharp image on the screen. Do you think this will give you a sharp image on the screen?
Very, very sharp.
Very, very sharp, seriously. Sharp like the knife you put through my heart. Good. Hey, look at this answer, you're wrong. That's going to be half image on the screen.
Wonder.
Check on the straight line, not there. This focal point here should be extended all the way on this straight line, not super happy one. You go two things at the same time. You read the question. Yes, that's more a logical answer, isn't it, Melvin? Yes. LEN, lens, is it? Also. Okay, everyone, due to the time constraint, once again, go through the answers real quickly. Oh, very good, Leo. You are correct. Okay, everyone, for those who are struggling, let me tell you, this is an unconventional question, guys. This is an unconventional question because usually, right, how the question for lens will be is that our object will be here, then you have to draw the stupid straight lines and do something like this one, right? This is what we usually draw. Now, this diagram that I just drew will only be true if
the object is not on the equilibrium position like this one here. You see this object right now here is in the equilibrium position, indicating that this light ray will not work the same anymore. Okay, so what you're supposed to do is you're supposed to first read the question and say it says that a converging lens projects a sharp image of object O onto the screen. And in order to have a sharp image produced onto the screen, that means to say the light rays must hit exactly onto the screen, right? So what you are actually expected to do is you're supposed to draw one straight line until it reaches the normal here. Same for this one straight line until it reaches the normal here, right? Then after that, straight away converge it all the way down to the focal point here. Same thing for this one also. Why this is an acceptable answer is because by the very definition, guys, a focal point is where all light rays converge into a specific point. That is what we call the focal point, right? So if the object is on the equilibrium, by right, the image should be projected onto the equilibrium also. This is something that you all must know. Okay, this is an unconventional question because most of the time we just draw the stupid straight line cut that thing, right? Everyone knows how to draw the straight line one, but when the object is on the equilibrium, it will not follow the same rules, guys. Same thing for this one also. Right now, it says that it's replaced by a thinner converging lens, right? But this time it says that it has a longer focal length than the converging lens in A. If just now the focal length is here, this was the focal length. If I have a longer focal length, it means to say it should be even further away from the screen, right? And thus what you should do is you should draw the focal point somewhere along the equilibrium position. Once again, draw straight line until the normal, then cut through all the way until we reach the focal point there, guys. We're supposed to get something like this, right? But in a nicer way, right? What? It doesn't matter. I'm just. In fact, you don't have to draw this line also, but you need to converge it at the back of the screen because it has a longer focal point. Okay. Then after that, question C is no longer related to A and B, by the way. It says that a converging lens is a magnifying glass. I've said this before in your exam. They love to ask about magnifying glass. And it says it has a focal length of 10 cm. Describe the position of the object in relationship to the lens. Where should the object be placed if it should be a magnifying glass? I've said this a lot of times in the class also. Where? In between where and where? In between the focal point and the... Do you know what a focal length is? A focal length is from the optical center to the focal point. Optical center, bro. You know what's the optical center or not? Optical center is here. It's the middle of the lens. The object should always be placed in between those 2 points, right? Then after that, describe the position of the image with relationship to the lens and the object. It should be further away from the object. Sorry, further away from the lens than the object, from the lens than the object. If you remember, if this is the
the magnifying glass, it will look something like this, right? You better remember this by the way. 7 out of 10 times comes out in exam one. And give the 3 properties of a magnifying glass, for sure it's going to be real or virtual. Virtual. Magnified or diminished. Upright or inverted. Yes, and then you score your 3 marks here. Okay, everyone. Anybody's got any questions here? Guys, I'll be stopping here today, okay? So please, if you have the time, continue doing all the questions here. I handpicked these questions because they are relatively more unconventional than the others. If you want, you can request the mark scheme for me to check your answers, but I highly recommend doing all the questions here. Okay, boys and girls, that will be it for today. I'll see you all during the next class. Not the last class, bro. Oh, sorry, in terms of the intensive class, yeah. This will be the last intensive class because next Sunday onwards, I have something to do all the way already. So I'll just see you guys in the normal classes. In the normal classes. Okay, welcome. Goodbye.
Bye.
Bye-bye. You can ask me if you have any questions with regards to these questions here.